Good evening, students. Thanks for waiting. I really appreciate your patience in receiving my lectures for today. At the same time, I have to ask for apology for being late due to my health problem. Hope you will admit and attend this class online at your convenient time before 9 a.m. tomorrow. This class is on Engineers in Society revision class. As I mentioned before, we will have revision on based on your assessments, and then further for your preparation for the examination, so that you're well prepared and mastering. Okay, if you have any question, kindly jot down in CN or send personal message to my email ID. I'm always reachable. I will reply immediately all your queries on time. Let's continue our class. This is a revision class for this module for this semester. I have planned the revision class for mainly on the chapters 3 and important topics and all other topics as well. Okay, very first you should know what are the course outcome due to this module. For final exam, as usual, we will cover all the course outcome of the module. If you see this, first one is to mastering main professional bodies that are important for engineers of any type, maybe electrical engineer, civil engineer, chemical engineer, or mechanical engineer. It's all about safety, health, public works, and the environment. So all these things will be done in CL1 or course outcome 1. You know all about the professional bodies and the duties. Second, importance of the standards, code of contacts. Above all this, you have the main board of engineers, especially on Board of Engineers Malaysia, since the course is offered in Malaysia. This course will provide you the code of conduct as instructed by Board of Engineers Malaysia. Later you can adapt. If you are employed in UK, Australia, Netherlands, you can adapt their own codes of contact when you get employment over there. Here in this course, we are teaching you all the Malaysian codes. And CL3 will be on the design process, importance of design process, because we are engineers, we are makers, we are creators, we are designers, so should be knowing the process and how you are going to manage a project. Lastly, all about social environmental implications, right? The consequences, the major issues that an engineer is facing, and the solutions from OSH and also from other boards will be dealt in the course learning outcome 4. So altogether you are learning the roles and duties and important boards that governs the rules and regulations of engineers. Let's move on. All your worries about how the examination format will be. As usual, you'll be writing for 100%. Final examination will be written for 100%, and then the proportion of the examination will be taken from 100%. I think it's 40%ish. If you want, I can check and confirm you in the next class. You're doing coursework for 40%, 60%, I think. 60% of the examination, 40% of coursework. So first, this question pattern is all are theory with subsections from A to B or C or D. Each question will have 2 subsections, 3 or 4 subsections. Overall, you'll be writing 5 questions. You need to attend all questions. Each will have either short or long type. You can decide based on the marks given. But please write your answers in specific terms using keywords underlined in bullet points. Simple English will do. You practice that way. So each question will be marked for 20, thus you have 100% mark for the examination. The mode of examination due to this MCO will be instructed later on by IRBAN. Please wait until the notification officially come through CN for you. Moving on, you have code of contact. Start with code of contact for from Board of Engineers Malaysia. I think the C has to be cut. There's a mistake in it. Let me correct it. It's not C, it's Board of Engineers Malaysia. Okay, correct here. Let's have a overview on how the Board of Engineers Malaysia is working and what are the regulations. I brought down here those 5 important things, 5 important codes that you should always remember in your mind. Number 1 is registered engineers. How a registered engineer, maybe a graduate engineer, start from the responsibility starts from registered engineer, professional engineer. You may register initially as graduate engineer immediately after your graduation, and after getting some experience, you will be endorsed or you get an endorsement as professional engineer to handle projects, become signatory of projects, consultants, and so on. Okay, a registered engineer shall at all times hold paramount the safety, health, and welfare of the public. So you should be, as a registered engineer, you are responsible for safety, health, and welfare of the public. So all rules and regulations related the issues and the rules and the actions related to safety, health, and welfare of the public in the environment is important for an engineer. For example, if you go into the approval and sign only those engineering document that has prepared by the professional engineer. If somebody has done and you simply sign, it is not properly endorsed by professional engineer, you should not accept it. Likewise, all about the responsibility of an engineer to protect safety, health, and welfare of the public are stated here, mainly on the follow adapting the code of contacts. You should be approving the document. You should be what else? In any situation, you must refer to this code and follow the instructions, follow the rules brought by the code of contact. All the consequences are expected as a result of this advice being overruled or amended. So you need to follow these rules, guidelines to decide, take decision at times of or any issues related to safety, health, or welfare encountered. Right. Registered engineer shall undertake assignment only if he is qualified by education and experienced in specific technical fields in which he is involved. So registered engineers, so we learned that registered engineer should be true to his profession only if any project, number 1 is he should not sign for any document if he's not a professional engineer. Number 2, any project he's accepting is also should be endorsed by professional engineer, stamped by professional engineer. Otherwise, he should not accept for any supervision or execution of the projects. Check whether it is professionally endorsed by the professional engineer or not. Number 3, a registered engineer shall issue public statements only in an objective or truthful manner. So registered engineers should be genuine. His statement, his verdict, his findings, his knowledge in terms of patents, trademarks, or copyright should be true verdict. It's not foolproof or copy others, plagiarize. Hi everybody. Hello. And let me continue with the previous section that I stopped. We are looking into number 3, code of conduct number 3. To be an engineer, to be genuine, to be true to his own attitude, activities, and also his arguments, statements, or any copyright or patent that he is filing should be true to his knowledge and not falsify any of the documents that he is giving to public or giving to government. Number 4, registered engineers, in addition to being himself true to his work, he should be true to his employer, his clients, consultants, and also the trustees or the customers. And registered, according to number 4, Act number 4, you should be reliable to his employer, to his trustee, consultant. All the rules and regulations are different situations, like number 1, at times of conflicts and interests, at times of taking in his judgment and accept the compensation. You should not accept the compensation, financial. You should be a valuable person, right? Not bribery, and followed by the advisors. A registered engineer as advisor or director of a company or an agency shall not participate in decision with respect to particular services solicited or provided by him or his organization. You should follow the policies, the company's code of conduct, not misusing. And then in terms of contracts, so by all means he should be true to his company, that is for sure. Number 3 says about himself. Number 4, in connection with the company, his role at his job place should be genuine, for not an unreliable person, not behave like a falsified person. Number 5, a registered engineer shall conduct himself honorably, responsibly, ethically, and lawfully, so as to enhance the honor, reputation, and usefulness of the profession. So he has to conduct himself, whatever he is conducting, he should be responsible, following ethics, following law, eventually protecting the reputation, name of the company, of his profession. That's the company or the government attached with which he is attached will be growing, blossoming. He should not get into any type of misusing his qualification or get into briberies like commission, percentage, brokerage. So overall, it tells 1 to 5 code of conduct brought from Board of Engineers Malaysia gives you how a professional engineer as an individual at his job place, with respect to company, with respect to his boss, manager, line manager, should be is instructed from Board of Engineers Malaysia. For your examination, you may have to follow 1, 4, and 5 thoroughly. 2 and 3 may be for your reading. 1, 4, 5 should be thoroughly understood and practiced for your examination. You can, if you cannot pick any of the things that in the subsection, you just mention the main section if any incident or any case study is given to you in the examination. Just relate to how it is related to and which code of conduct. The main section can be written, if not the subsection, because subsection may be 1 or 2 connected, interconnected. It's good enough if you mention the main section of the plus. Okay, proceed with, you can read through this. Excuse me. For any of the regulations related to your profession as a professional engineer or detail here, you can go through. Let's continue with the second topic. Who is a civil engineer? Let's start with classifying types of engineers. As I mentioned in the class before, you can you can classify the type of engineer based on their study, based on their work, based on their organization they are going to become a member or professional. Also forms a good answer for this question. Start with civil engineer. Just see the civil engineers. Then, okay, before I start, you know the classification of engineers. You are going to see mainly the four engineers who are all sitting here in the class: civil engineer, mechanical engineer, electrical and electronics engineer, and chemical engineer. We're going to see four types of engineer, their roles, their study, and so on. Okay, you when you write the answer, I repeat, you can give their role, responsibility, study field, and the organization wherein they can become member or register themselves as a professional engineer. With that, you can nicely differentiate people at different portfolio. So civil engineer. Civil engineers, start with civil engineer. They are the pioneer of all engineers. If you take the story, it will be very interesting. Civil engineers are the number one engineer in the globe. It started from US. You remember US Cadet Corps. For protecting the country, they started with US Army, and these people are later trained to become engineers or designers to build their tunnels, drainages, uh, escape ways, and so on, mainly because of the army purpose. Then they are named as civil engineers. Later on, mechanical engineer, electrical engineer, and so on, grown as the technology keep growing. Okay, start with all engineers. Before I start, all types of engineers. All engineers have to have the same portfolio as a planner, designer, constructor, execution. You need to execute, you need to check the drawings, you need to monitor, maintain, check for safety, environment, health, public welfare. All components are very common for all engineers. What component, what target they're going to achieve, whether they are going to differ. Start with civil engineer. They are going to plan, design, construct, structure, and infrastructure. Both structures, main columns, building column, beam, slabs. Infrastructure, all the telephone lines, drainage lines, electrical lines, water lines, and so on. Okay, they also construct building structures like water resources, construction, transportation, geotechnical, which involves all types of slope stability, earthquake structure, how the retaining walls, how the structure will withstand the heavy downpour, flood, hurricane, wind, and so on. And then they also design and supervise the roads, buildings, airports, tunnels, dams, bridges. You can write list down all types of buildings and also infrastructure. And then development, not only home country look to beautiful, but provide or create better, safer place for now and future. So all the portfolio is to do, construct, maintain, and monitor the structure, solid structures. It may be water holding, air holding, air retaining, or earth retaining, or structural elements. So all about construction will be done by civil engineers. You can add more lines in respect to organizations like Board of Engineers, Civil Engineers, ASE, American Society for Civil Engineers, IET also have civil engineering chapter, IIT Malaysia also have civil engineering chapter. So you can write down the sections of civil engineers and the organization they can attach with as a member and also register as professional. Second engineer, electrical and electronics engineer. Okay, as the technology is growing, we also have different types of engineer. I stop here before I continue with, we'll continue in the next slide. Let's continue with electrical and electronics engineer. Next to civil engineer, we can say mechanical engineer actually, because when they started with the construction, they wanted to have some kind of heavy machines and tools that mechanical engineers grown up. We can also say next is mechanical engineer. Let me continue with electrical and electronics engineer, who are all mostly related in power systems, telecommunication, electronics equipments like chip, all types of cathode tubes, anode tubes, and so on, signal processing, control systems, aviation electronics, all related to electronics instrumentation, microprocessor, systems engineering, power systems engineering, telecom, all or their portfolio. More add to this global position system, electrical and electronics equipments, modifiers, electrical drawings. So as I said before, they are also having some kind of graphs, charts, calculations, system schema, specifications in developing their own microprocessor chip or a telecommunication device or any type of instrumentation involved. So their portfolio, their duty is to plan, design, execute all these types of electronics and electrical related, power related, and their instrumentation. Electrical engineer design modify human machine. They also provide the core part or the chip for or robotics or automated systems design. And the example, standard example is a SCADA, data acquisition system, which uses software program will be bound to the microprocessor. That part of microprocessor is developed by electronics engineers. So all about development of software chips, microprocessor, all types of electronic instrumentation will be done by electrical and electronics engineer. You are getting electricity at home by electrical engineer, very simple. Transmission of electrical energy from the source, right, from the generation point, it might be any type of electrical energy until the supply, all through the supply and to the community is all by electrical engineers work. Next is the mechanical engineer. Mechanical engineer generally specializes in own area of engineering, mainly to say machines, tools, instruments related to heavy duty, right? Heavy duty and the tools and fixtures and so on. Examples, if you see, they developed the nuclear reactors, car engines, and then power shaw, elevators, printing press, hydraulic press, air condition, all are designed by wherever the motor related, right? Electrical engineer gives power to operate, right? To run physically, to run the instrument, we need to have a mechanical component or the motor, all developed by motor pumps, are all developed by mechanical engineers, and is powered by electrical engineers, bulldozers, and so on. So you can see all types of mechanical related tools and machines. Instrumentation will be by mechanical engineers. You can read more on the examples of mechanical engineer products, followed by chemical engineer, and is the last engineer. We can say chemical engineer. When you say chemical engineer, all things related to all products, process related to chemical, pharmacy, and then compounds, organic, inorganic compounds related processing, food, drinks, medicines, pharmaceuticals, all are by chemical engineering. All types of processing of food, drinks, medicines, and other parts of processing will be by chemical engineers. So this involves number one, chemical manufacturing, product supervision, and they also do supervision of the product, especially details finding certain evaluations. Okay, task evaluations also they can do. They can publish the results. Chemical engineers work in a variety of manufacturing industries. um, yeah, as I said before, it's food, clothing, paper, wherever the chemical related processing or production is involved. Chemical engineers come into picture. They also do estimation. All engineers will do their own estimation. Electrical line, they have to come out with the electrical engineer will come out with the electrical circuit and the estimation of laying, commissioning of the circuit. Chemical engineer same. If they develop any plant, they have to come up with the design, cost involved in designing, constructing, execution of the plant, and so on. I stop here for types of engineer. If you have question, I repeat, you can post in the comment. You can post in the comment or do it in the reflections at CN. Let's continue with the second topic. Our second topic is on types of law act. In this class, we brought down 5 types of laws and acts that you must be knowing as an engineer. Overall, it is applicable for all types of engineers, not only for civil or mechanical engineering. Number one, Occupational Safety and Health Act, OSHA. OSHA. It was developed in 1994. Second one, Factories and Machinery Act, FMA in 1967. The evolution period also given here. Petroleum Safety Measures Act in 1984. Environmental Quality Act, EQA, in 1974, and the Uniform Building Bylaws, UBBL, 1984. Let's see one by one what is their statement, what it protects, what it says. Okay. Number one, Occupational Safety and Health Act, OSHA. It says about safety, health regulations, all Safety Health Regulations Act, DOSH, Department of Occupational Safety and Health, have the control of all these things, implements and monitors in any country, in any territory. It defines the general duties of employers, mainly on the employer's duty in protecting the safety, health of the employees at work, to secure the same of the persons at work, for protecting others against risk of safety health in connection with the activities of persons at work. So it is like this. The safety and health, the Department of Safety and Health, make sure that the employees are safe and also that the activities that they are doing, the projects that they are handling is also abide by this act as stated in this act. The window size should be this much at this level, should follow the same. The door size, for example. Nowadays, many accidents are due to high-rise buildings. If we see as the building is growing, the death ratio of the workers falling from high or increasing. You might have read in newspapers. This OSHA is the best rule come into picture, come into effect to protect people at work, especially in building. If you see, the number one loss of life in engineering field is construction field. It's mainly because of many high-rise building, and there are competitions due to that. Every country started building their own towers and high-rise buildings. Because of this, human health safety is getting affected. So they are all instructed in this code of contact, how many floors to rise, how many, Let's move on to the next law. After OSHA, the first and foremost thing that comes to any mechanical engineer is Factory and Machinery Act, because they are the people who is working with dealing with machines. Factories and Machineries Act, FMA, released in 1967. This act provides for control of factories with respect to matters relating to safety, health, welfare of a person, therein the registration and inspection of machinery, and for matters connected with this related to machines at a factory or company that has to be purchased under quality, used at good working condition, and monitor all through its life period until it is thrown off, discarded from use. So all the regulations of monitoring, maintaining machines in good condition, calibration, testing at work will be instructed by Factories and Machineries Act. It's related to equipments at the machines, equipments and machines at the factory and companies. So those instructions are given here. You need to abide by the regulations. How many machines and what kind of capacity, and in proportion with the users, and so on. Third one, Petroleum Safety Measures Act. Petroleum engineers will be more using this type of act. It says an act to consolidate laws relating to safety in transportation, storage, and utilization of petroleum. So it's mainly on the storage, transportation, safety in storage, transportation, utilization of petroleum from production to usage. Environmental Quality Act in 1974, well before you all born, all the law and regulations are brought down well before you all born. So it's your duty to upgrade, maintain, and follow up in your roles as engineer in future. EQA mainly addresses the pollution. Okay, environmental. When you talk about environmental factor, the main factors are air, water, and land. You can include forest. All these things have to be maintained, keep away from pollution, maintain the index. All these things are dictated by Environmental Quality Act. Department of Environment of the country have to implement and practice at the public level. Lastly, the Uniform Building Bylaws in 1984. Uniform building bylaws were introduced to provide a common legislation for construction and inspection of structures across the country, covering a wide range of technical requirements related to public safety, including fire prevention, structural integrity, proper electrical wiring, ventilation, and sanitation facilities. In addition to already designers are following, civil engineers are following code of conduct, code books for their design, for their estimation, everything. In addition to that, building bylaws are there, something like their Bible, to cross-check and verify after construction, especially after construction, whether all the design and drawing are up to the one moment. Building bylaws, sorry for interference. Building bylaws are up to the courts, up to the recommendations as per UBBL, especially on the complete. When you check the completed drawings of any building, it should have proper structural integrity. The column should be in the column place, or beam should be beam place. Proper electrical wiring, ventilation, sanitary facilities should be at the proper place at proper level for proper disposal. All these things will be checked by UBBL. Mainly this will attend completed structure or drawings of completed drawings. They will usually draw in red color against the original drawing to mention any kind of differences if it is produced in the drawing or constructed at the site. Okay, we are moving on to the third topic that's most important for you all. It's a good example for you. There are many examples you can come across, you can see in your day-to-day life. You can also take any examples, the current issues like COVID, right? COVID, health issues also can be taken into consideration for your analysis. Or what, as a biomedical engineer, if you take the biomedical engineer, he has to follow all his rules and regulations, code of contacts to be a successful biomedical engineer at this point of time. So one of the case study, one of the exercises brought down here, it's about the production engineer. You can see, I already told you many times in the class, if you see you are an electrical engineer, you should also be knowing some knowledge or having some knowledge on other types of engineering roles and their portfolio or their design, their roles as an engineer. If not in detail, in depth, at least you should be knowing what are they doing. Then you will know at times of need. At times you may be working as a mechanical engineer manager at the mechanical instrumentation company, but என்னடா I'm sorry for the interference again. My son suddenly pop in. I have to stop him. Okay, let's continue the BM code of conduct. An incident is being discussed here. I have given you an example one. There are many cases you can also take and analyze at times of your situation. If you were in a situation, you can check yourself how to apply those code of contacts from 1 to 5. As I said before, for your examination purpose, you please practice on 1, 4 and 5, 2 and 3 for your reading. So let's start with this. Number 1, what is the situation is explained here. Later you may have to answer with reference to the code. The codes are already given to you along with the examination if it is asked in the exam. Please refer to the code and then answer properly. You just highlight on the main points. Let's go into this case study. Albert worked as a production engineer in a factory producing precast RC reinforced concrete units for industrial building systems. About 3 months after starting work, Albert noticed a leak in one of the machines and engine oil is seen pouring into a drain that eventually flow into a nearby river. Okay, it's relevant to the situation wherein there is a construction going on, factory producing not construction, producing the production is RCC beams and columns are produced, slabs are produced, they are manufacturing RCC precast members. In their production, they're actually casting at one part of the casting machineries. They found a leaking. One moment. They found a leaking of engine oil. Where the machines are running, engine oils are used. It may be engine oils, maybe you as a fuel or as a lubricant they are using. At one part, it is leaking, and the leakage is leading into a nearby river. That means there is no proper drainage, proper disposal of the waste from the factory. That's one point you can notice here. Directly leaking into the nearby river because there is no channel for the type of leakage, or it is not expected. The leakage at that point is not expected by the company. That's why it is automatic flow due to the leakage that leads into the river. It is not properly channelized. Albert immediately reported this problem to his immediate supervisor, Miss Alex, the plant manager. Albert is your engineer like you, and you reported to your manager, he's Alex. But he says top priority is to complete the order, keep the company sales target, maintain its production record. He also told Alex that can do the repairs, the oil leaks from machines after the order is delivered. So don't worry about the leakage. You just keep going on the production side, achieve the target. Maybe they are producing some 100 cubes today. They have to make 100 beams or columns. Achieve the target rather than working on the or fixing the problem or wasting time on the using time. It's not wasting time, utilizing your time in the problem occurred. He asked him to ignore the problem, proceed with the production, as though he did not know the consequence, as though he did not know the the linking between the production and the problem cause. Right. This is the situation. Now, how do you address this situation? What are the kind of dilemma you notice here? What should be followed according to the codes that you are learning now? Number 1 to 5. Which codes need to be applied and what may be your answer? Let's see. Number 1. You can discuss only the main codes that is relevant to the situation. Herein we can say it's relating to number 1 code and number 4 code. Let me discuss on the number 1 code. Registered engineer shall at all times hold paramount responsibility of the safety, health, and welfare of the public. In line with this, you see, if I follow Miss Alex's instruction to continue the production, I means Albert, it will please the company, but it will endanger safety, health, and welfare of the public as the leaked engine oil will pollute the river and the adverse effect of the environment. On the other hand, if I repair, I will be unable to deliver the order on time. The bulk order that they received, they cannot achieve it. So there is a trade-off he needs to follow. This will not be a good for a company from business point of view. We stop work and attend the repair work. It will not be good at the company point of view, but at the environmental point of view, the company is polluting the river. Nowadays, if you pollute the river, you have to pay the penalty, right? So you should know the consequence. You should know how quickly you can estimate the consequence and how important that particular situation is in terms of environment, in terms of more economic, in terms of public health, and so on. Overall, you should play a balanced role. Knowing all these facts, you should play a balanced role, not only targeting the economy, not only targeting the public, and so on. To strike a balance without stopping production and at the same time not pollute the river, the best option is to install or fix a temporary container to collect all the leaked engine oil and at the same time just keep the container to collect. Instead of channelizing into a river, you just provide a collector, quickly provide a collector. Someone managed to get a collector to keep it there. Time spent is to produce a collector there so that all the leaking oil will be collected by the collector, and then the order production of the precast to achieve the target is also going on. After that, you can stop the production and do the repairs. So after all production is achieved, target is achieved, you can go for repairs. So you must quickly think, ingeniously think to provide a solution for both. Achieve the target, eventually you don't follow the river. Number 4, the dilemma. If you see, this is as instructed by code 4 in BEM. A registered engineer shall act for each employer or a client as faithful agent or trustee. So he is supposed to act as a faithful engineer, trustee. According to that, he should not fool himself, or he shouldn't act himself as though he doesn't know the consequence, as though he did not bother about the consequence. Just let's read to the paragraph. As I am facing the ethical dilemma, what to do? I have to choose between servicing my employer with complete fidelity, so he is abide by rules and regulations of the company. The policy may be to improve their production. At the same time, he, as an engineer, he has to protect the environment. I have an obligation to hold paramount of the safety of the welfare of the public. If I report the problem to the authority, it will upset my superior, which may in turn affect his career, isn't it? So, registered engineer cannot be loyal to his company, not following his boss instruction, as concentrate on the production rather than the other part, fixing the problem. Furthermore, I have to loyal and cannot give information about the company to outsiders. Outsiders, on the other hand, so according to Ford, he should be loyal to his company at the same time fixing the problem. How can it be done? By providing a balance between this conflicting obligation. However, it is clear where conflicting is between loyalty of the employer or client and the protection of the public. Okay, he got in between loyalty to the employer and protection of the public. The latter must be viewed in this case as the higher obligation. So when you compare these two, production can be improved by increasing the man hours, or they can do later. But protection of public, once you spoil. Okay, let's continue with the last completing remarks of this class. So according to Code of Four, based on this incident, there are two conflicting situations: to be loyal to his company or to his public. When it comes into play, you really think of the consequence. When you see the complying to the employer's order, you can even produce by increasing the man hours later on, and the production will be booming up. But once you spoil the river with oil, the consequence of treating a consequence, nowadays it's illegal. You may have to answer the government, you may have your abide by rules and regulations for discharging or polluting the river. Above all, it's always a challenge for production engineer or for what environmental engineer to separate oil from any of the medium. It may be water or any other processing liquid. There is no good technology right until today to separate oil. Once the liquid is polluted, oil is polluted, I mean the river is polluted, water is polluted, separation of oil from that medium is very difficult, complicated. There is no one technology, in spite of having nanotechnology, very good modern technologies, advanced technologies. We still fail to completely remove any water body or any liquid medium which is polluted by oil. Hence, you need to play a balancing role between these two effects. These two responsibilities occurred at the same time. By providing alternate solution ingeniously, a temporary contingency plan should be in your hand for protecting the public and also attending the employer's order. I stop here. If you have any question, you can ask me through the comment box or by emailing or by messaging me. You have my number, email ID. I am reachable. Please keep in touch. Wishing you good luck. Thank you for attending the class. At the same time, I thank you for your feedbacks every day, really motivating me, correcting me. Your feedbacks will help me to retain the good practices, correct my mistakes, improve my performance in teaching. Thank you so much. Have a nice weekend.